And finally, I want to talk about function pointers. That might be a bit surprising for you, but they are coming to the language. It's basically the ability to use function pointers. Let me show you something first. So obviously, you know that we have actions and functions, basically delegates in C# to kind of represent the concept of function pointers. And they are used all over the places, right? In LINQ and any modern C# application use lambdas a lot, lambdas and delegates. As you can see in this example, I'm defining our f as a func that takes an integer and return an integer. And I'm using the method group to assign, the method to the lambda. That means whenever I use f, is effectively going to call whatever method I associated to it. So if I call f10, it's going to return 100. Under the covers, when you invoke delegates, the underlying IL is going to use the call virtual code in order to actually invoke the delegate. However, there are scenarios when you need to invoke like some native functions where you want to take advantage of some different calling conventions to improve performance as well. So in that situation, you want to consider using function pointers instead. So the syntax is very similar to delegates. Basically, you use delegate star, and then you use the same syntax as you use for action and function to specify the parameters. So in this case, with delegate star int, I'm defining a function pointer to a method that takes an integer and return an integer. And then you use the ampersand to get the address of a particular method to assign it to the variable. But what happened under the covers, this is obviously unsafe code. What happened under the covers is the IL code that will be used is call I. That is obviously a different kind of calling convention and doesn't do any virtual stuff. So the code is more efficient when you use this. And then C# goes a bit crazy by providing the ability to specify explicitly what the calling convention is going to be when the function pointer is invoked. So by default, if you don't specify anything, it's going to be managed using the default kind of calling convention in the .NET framework. So delegate star managed is the same as delegate star. That's basically what I've shown you in the previous slide. However, you can make the function pointers unmanaged, and if you do that, it's going to change the calling convention based on the runtime where the code is running. Or you can specify in square brackets the specific calling convention that you want to call. And there are different calling conventions defined in the ECMA 355 standard, that is the Common Language Infrastructure standard, has been created since the beginning of .NET. Standard C or standard C++ or special optimized C++, or this call if you need to kind of use a function pointer to an instance method. So you can actually use this sort of low-level function pointers if you really need to interop with other code in a more unmanaged way. I mean, this is something you can probably safely ignore because you can always create an easy wrapper to never expose this sort of details from consumers of libraries. But this is stuff that Microsoft added to the language to provide a way for developers of libraries, that low-level libraries or frameworks, to really improve performance significantly or improve interoperability between different languages. In the future, .NET 6, I think there is plan to improve interoperability with other languages in the pipeline.